Class is up online now. I did it before this class started, so. All right, so we're going to look at the first topic is actually dealing with domain and range. So I'm actually going to open up a new tab because I'm going to actually show you using Desmos what these functions look like. So this one, this lesson is going to be pretty much all about solving trig or graphing trig functions. So if we look at the first trig function, let's look at sine of x. Now, when we do these, I'm going to actually look at just negative pi over 2 to 3 pi.
Excuse me, Professor.
Yeah.
All I see is your black screen with your initials in the middle of it.
All right.
I don't see anything else.
Okay.
And we're on Microsoft Teams, correct?
Yeah. Let me just redo the. Let me reshare my screen. See it now?
Okay. Yes, I do.
Okay.
Thank you.
Not a problem. All right. So this is sine of x. So we're looking at sine of x. A few things that we want to look at is we want to look at the range of the domain. So the domain, notice that the function keeps going on forever. So for sine of x, my domain is all real numbers. My range goes from -1 to +1. So that's going to be my range of the standard sine of x function. Now, if we look at cosine of x, you're going to notice something very similar about it. So cosine of x is actually the same shape, it's just shifted. So cosine of x and sine of x are very similar in their functions. And again, the domain is all real numbers, and the range goes from -1 to +1. If we look at tangent of x, we're going to notice something different. Tangent of x, I turn off sine and cosine, those now goes up. So tangent of x actually has values that do not work. So we're going to have domain restrictions when we're looking at tangent. However, my range is all real numbers. So if you remember from the last lesson when we were looking at tangent, my tangent is y over x, or sine over cosine. So where cosine is 0, my tangent doesn't work. So if we look at cosine, turn back on the cosine, you'll notice where cosine equals 0. So if we look like right here, cosine equals 0 there, and cosine equals 0 there. Notice how my tangent seems to have that vertical asymptote. So it's basically every pi, the pi over 2, 3 pi over 2, and so on and so forth, is going to give me that vertical asymptote. So those are my restrictions on my domain. So when we're looking at tangent, when we're looking at the quadrants, you typically look at your fourth quadrant and your first quadrant to do tangent, because that's going to give me my full curve on it. Where cosine, we look at the first and the second quadrant, as again, that gives me my full curve. So if we go back to the problem for this one, and open a new tab on me. There you go. So secant, oh, I forgot to do the inverse ones. So let's look at the other ones. So we've got secant or cosecant of x. So now cosecant of x is the inverse of sine. So we're going to look at the same things. Where sine is 0, I get my vertical asymptotes with secant. So my domain is going to have restrictions, but my range is actually going to go from everything up to -1, and then from everything from 1 to infinity. So it's not even all real numbers on my range in the secant or cosecant. Secant is the same thing. So if we look at secant as compared, so secant goes with cosine. Again, same thing. Where cosine is 0, I have my vertical asymptotes. And again, my range is from -infinity to -1, and then 1 to infinity. Then we have cotangent. Cotangent is very similar to tangent, except it's, again, the reciprocal of it. So we're looking at cosine being on the bottom of this one instead of, or sine being on the bottom of this one instead of cosine being on the bottom. So that's where we're going to, it shifts my vertical asymptotes. So my vertical asymptotes are in a little bit of different place on those. But this one, my domain as a restriction, my range is all real numbers. So the first one we were looking at for this problem was secant, sine, and tangent. So secant, if you look at the graph, let's look at the graph for secant. So secant was the opposite of cosine. So it's where, so pi over 2, 3 pi over 2. So it starts off at pi over 2, and then it adds pi to every one. That's my domain restrictions. So we look here, and it says a set of real numbers except for the odd integer multiples of pi over 2. So if we look at my graph, that's the odd integer multiples is 1, 3, 5, 7, and it keeps going on and on. Does that make sense? Yes? No? All right. Okay. My range is a set of all real numbers, not from -1 to 1. It's a set of all numbers less than -1 and greater than or equal to 1. So it's the inverse of the sine and the cosine of that section. Cosine is 90 degrees off of sine. Sorry, Brian, I just looked at the chat. Now sine, my domain is all real numbers. And my range is from -1 to 1. Now tangent, we look at tangent. And it's going to be, where the zeros for tangent are. So if we think about it, my tangent and my secant ones are very similar in that respect. It's where the cosine is 0. So again, it's the same thing. It's the odd multiples of pi over 2. And then my range is all real numbers because it goes all the way from the top to the bottom. So for this topic, what I would do is I would actually use Desmos and actually look at the graphs to try to figure out which ones are the domains and the ranges for them. All right, so now we're going to start graphing these. When we're graphing them, actually, all right. We're going to graph these functions very similar to the way that we graph the square root functions and those. We're going to look for the parent function and then do my transformations. So the parent functions for sine of x, we have our x and our y. So we have 0, and they want the minimums and maximums within one cycle. So if we look at the sine function, my special points are 0, pi over 2, pi, 3 pi over 2, and 2 pi. At 0, my sign is going to be 0. At pi over 2, it's 1. Pi is 0. That one's -1, and that one's 0. So that's the parent function for sine. Now, I look at my transformation. So it says the 1/2's outside. So when I'm doing this, I'm actually going to do 1/2 of y. So that stays 0. That becomes 1/2, 0, -1/2, and 0. So we still use the parent function, and then I just do my transformations to it. Now we're looking at this, we're going to use the plot tool to do this because it's not going to plot exactly as you'd want it. So we've got 0, 0. We've got pi divided by 2 over 1/2. We've got pi 0, 3 pi over 2, -1/2. And then we've got 2 pi and then 0. Now, once you've graphed them all, hit the tool and it should give you a nice curve. If it doesn't give you a nice curve, you probably made a mistake in one of your points. So that's the parent function for sine, and then you're going to do it. Those numbers are never going to change. So I would always use those breakdown numbers for sine. Let's actually go back for a second. I want to see if they're going to give me a cosine one. Good. All right, so cosine, the parent functions for cosine, is we're going to use the same values. So I do, but cosine starts off at 1. So 3 pi over 2, and then 2 pi. So it starts off at 1, goes to 0, goes to -1, 0, and then back up to 1. So that's my cosine one. And now this one, my y's are multiplied by 3 over 2. So that's 3 over 2, 0, -3 over 2, 0, and 3 over 2. So I would write down the parent functions for these because they're going to be helpful basically for almost all the topics we're doing tonight. We're going to be using those parent functions. So we got pi over 2, 0, pi, -3 over 2, 0, 2 pi, and 3 over 2. And again, we got our nice little curve. In this problem, the multiplication's on the inside of my parentheses. So this one we're doing to the x value. So again, we're going to use my parent function for sine. So actually, you know what? Instead of rewriting this, I'm just going to go back. So now there's my parent function for sine. So now this one, it's 3 over 2x. So remember the x, we do the opposite. So we're doing 2/3 x. So that's going to still be 0. That will be pi over 3. That'd be 2/3 pi. This would be pi. And this would be 4/3 pi. So we're going to multiply all the x's by 2/3. So we've got 0, 0, pi over 3, 1. And once it's graphed, I'll show you what it actually does to the graph. We got 2/3 because it was the inverse of what they told me inside. So they got the 3 over 2 in the inside. So I'm doing the 2 over 3 because that would be the opposite of what they're doing. So now when we graph this one, the difference is that the curve gets shorter. So before we had one curve that went all the way up to 2 pi. And now that I've changed my number inside, it's going to get small. It actually shrinks. So the period is shorter. So the value that is multiplied by the x tells me my period. So in this case, my period is 2/3 because it's 2/3 of what my things. Yep, it's the same rule that we follow all the rest of the time. So it's actually no different than the rule that we followed when we were doing the square roots or the exponential functions or any of those. It's if it's inside next to the x, you do the opposite of it. So if it was subtraction, we'd add. If it was addition, we'd subtract. If it's multiplication, we divide. If it's division, we multiply. In this case, since it's both, we basically do the reciprocal of it. All right, let's keep going. Now this one, same thing, except it's more stuff. So we're using our cosine parent function. I've got the 1/2 inside of the x, so I'm going to do 2x. So that becomes 0, pi, 2 pi, 3 pi, and 4 pi. And then I'm going to do 3y. So it's 3, 0, -3, 0, and 3. So I'm using the 2x because that's the reciprocal of 1 over 2. So I flip that over, and I'm using the 3 because we do exactly what it says on the outside. So my points I graph are 0, 3, pi 0, 2 pi -3, 3 pi 0, and 4 pi 3. So you'll notice how this one gets longer. It's also getting taller. That number in the front is making your graph taller or shorter. So if you remember, the first one we did was 1/2, and it shrunk the graph. The next ones were bigger than 1, so it expanded the graph. It stretched the graph up and down. But this also stretched the graph out longer. So my period for this one is 4 pi instead of just 2 pi. So it's twice as long. And that's because the reciprocal of the 1/2 gives me that too. All right. So now this one is sine of x plus 1. So go back to my sine parent function. Now this one, it's the plus 1 is on the outside. If they wanted the plus 1 on the inside, they would have written it like this. They would have done x plus 1. Since there's not parentheses around that x plus 1, it's on the outside. So that x, or that 1, is being done to the y, not the x. So I'm going to do y plus 1. So it's 1, 2, 1, 0, 1 are my new points. So if you notice, it's basically, once you have the parent functions, to graph them, you're just doing those transformations to it. So you're not trying to come up with new things every single time. So just like I said in the last class, with the unit circle, I said, make sure you have the unit circle written down in front of you or printed out. I would have these parent functions written down. So this way you can just do the transformations to them really quickly. And you don't have to constantly try to think about which values you're using. So 0, 1. Pi over 2, 2. 1. 3 pi over 2. And then 2 pi 1. So what this does, when we're doing the number on the outside, when we're adding it, this is actually shifting my graph up or down. So if I'm adding 1, it's shifting my graph up. If I'm subtracting 1, it would be shifting the graph down. So in this case, I'm shifting it up by 1. The shifting and stuff like that, when we're looking at these graphs, is going to come in handy at the end when we have to take a graph and write the equation for it. So we're going to look at how it shifts and how it moves to come up with what my equations are. All right, so this one's a cosine one. Great. There we go. Finally caught up. Really? All right. So this one now we're going to do, it says plus 7 pi over 6. So since it says plus 7 pi over 6, since it's on the inside, I'm going to subtract 7 pi over 6. So it's going to be x minus 7 pi over 6. So the 0 is going to become negative 7 pi over 6. The pi over 2 is 3 pi over 6. So I'm subtracting 7 from that, so I get negative 4 pi over 6. Pi would be 6 over 6, so I get negative 1 pi over 6. 3 pi over 2 would be 9 pi over 2, so that's 2 pi over 2. And 2 pi over 2 would be 12 pi, so this would be 5 pi over 2. So in the other one, when we had something inside, it was taking the thing and expanding it or stretching it. If I'm adding something on the outside, it's moving it up or down. When I'm adding something on the inside, it's shifting it left or right. So since this is negative, or plus, you're shifting it to the left. So negative 7 pi over 6, and 1. Negative 4 pi over 6, and 0. Pi over 6. And yes, I could have just done pi there. And then we graph it, and something's wrong. So this is a perfect example of when you graph something and something doesn't work out right. So let's see. I did one of my subtractions wrong. So 12, that's 5 pi. All right, who can find my mistake? So that's negative 7. That's That's 3/2, so that's -4. That's 6/6. There's a 1/3 pi? Oh, that's the mistake. For some reason, I started doing 2s on the bottom instead of 6s. Good catch. So that should have been over 6 and over 6. So the last 2 points are wrong. So 2 pi over 6, 0, and 5 pi over 6, 1. Much better graph. So the nice thing is you shouldn't, like, unless you screw up all the points, odds are you're not going to get them wrong because you're going to be able to see quickly that that doesn't look like the graph you're supposed to have. And then go back and figure out what you did wrong, just like we just did there. So, and normally it's little mistakes like that that you're making. All right, what's the next one? So the next one is just doing more. So this one is sine. So we're doing 2 transformations to this one. So I'm going to do 5/2 times the y, and I'm doing x minus pi/2. So that's -pi/2, 0, pi/2, pi, and 3 pi/2. And this would be 0, 5/2, 0, -5/2, and 0. So you're just going to do your transformations to both sides. And I'm not going to graph this one because you guys know what it's going to actually look like at this point. Next topic, same thing. Again, just gets longer. So it's going to add more stuff to it. So in this one, I've got 3 things that I'm doing. Now, how you do them is actually very, very, very important. So when you're looking at doing the opposite inside to the x, normally PEMDAS says I do my multiplication first, and then I do my addition and subtraction. In this case, you're doing the opposite to it. You're actually going to do the subtraction first, and then the multiplication and division. So I'm going to do, for this one, x minus pi/4. And then I'm going to do 2/3 of that. So then I'm going to do 2/3 x. So this becomes -pi/4, pi/4, 3 pi/4, 5 pi/4, and 7 pi/4. And now I'm going to take all those and multiply it by 2/3. So I get -2 pi/12, 2 pi/12, 6 pi/12, 10 pi/12, and 14 pi/12. It might be your computer because I can see it on my screen too. And you obviously can't hear me talk to you that way. So. Unless nobody else can hear me, and then we're all in trouble. Okay. Awesome. Microsoft's been having tons of issues, so I don't leave anything to chance anymore at this point. Now we're going to do the y. So we're going to do 1/2 y. So 0, 1/2, 0, negative 1/2, and 0. So my points that I'm going to graph is negative 2 pi over 12, 0, 2 pi over 12, 1/2, 6 pi over 12, 0, 10 pi over 12, and negative 1/2, and then 14 pi over 12, and 0. So those are my 5 points that I'm going to graph. So again, it's just a matter of doing more and more transformations to the problems. My suggestion is I would go through and do, when you start the graphing problems, go through and do all of the graphing problems. Don't just stop at them, because then you're going to have to remember what you had to do on them at that point. So again, same thing. This one's just doing 2 things to the y. So let's actually go through and I'll do this one out, because doing 2 things to the y is a little different. So doing 2 things to the y, I'm actually going to do them in the order that they tell me to do them in. So for this one, I'm going to do 3 over 2, 3 over 2x. And then I'm going to do negative 3y minus, and then I'm going to do the y minus 1. So I'm going to do those as 2 different steps. So that's 0, 3 pi over 4, 3 pi over 2, 9 pi over 4, and 6 pi over 2. And on this side, I get negative 3, 0, 3, 0, negative 3, and then I subtract 1. So it's negative 4, negative 1, 2, negative 1, and negative 4. So the points that I would graph would be 0, negative 4, 3 pi over 4, negative 1, 3 pi over 2, 2, 9 pi over 4, negative 1, and then 6 pi over 2, negative 4. The good news is, Keegan, everything's being recorded today. So that's the only difference between the last one and this one, is this one you're doing 2 things to the y, and you do them in the correct order. You do the multiplication first, and then you do the addition and subtraction. All right, new function. Tangent. So now, tangent, when we're looking at the parent function for tangent, we have asymptotes. So again, when you're looking at, they want you to draw 2 consecutive asymptotes, and between those points, plot 3 points. So when we're looking at these, we actually don't want to use the 0 and up. We want to use, we're going to do negative pi over 2. We're then going to do, actually, yeah, negative pi over 4, 0, pi over 4, and then pi over 2. Because these are going to be your undefined. So those 2 points right there are going to be your undefined values. 0 is going to be 0. And then your negative pi over 4 and pi over 4 is actually going to be, so negative 1 and then 1. And the reason why is, if you look at the unit circle, let's see if I have my unit circle still up. I don't think I have my unit circle still up. I do not. If you look at the unit circle, your 4 points is going to be the same value. So it's negative pi over or square root of 2 over 2 over the square root of 2 over 2. So they kind of cancel each other out. And that's where it comes up to be the 1. So that's going to be your parent function for tangent. The other option that you have, if you can't see my thing here, I can fix it real quick. Give me a second. I will just unshare and reshare again for you. That seemed to fix the last problem. Can you see now, Keegan? Okay. Yeah, for some reason somebody else came in afterwards and just wasn't seeing the actual presentation. I know it was there because I'm actually logged in multiple times so I can see it. But for some reason it glitches when somebody else logs in apparently. But it's all recorded, so you can easily go back and look at it afterwards if you want. So there's my parent function for tangent. So now we're going to do the exact same thing we just did to sines. We're just going to change my values and my trig functions. So in this case, we've got 3x, so we're going to do 1/3 x. Remember, you do the inverse of it. So this is negative pi over 6, negative pi over 12, 0, pi over 12, and pi over 6. And then we're going to multiply all the y's by negative 1/2. So that's still undefined. That's now 1/2. That's 0. That's now negative 1/2, and that's still undefined. So we will graph this one because I want to show you how to graph it. So when we're doing these, I would plot all the points. So you can't obviously plot the asymptotes. So we're going to grab my asymptote. It's a vertical asymptote, and it's at negative pi over 6. And then my next one's at pi over 6. So those are my two vertical asymptotes. And now we're going to graph my other points. So negative pi over 12, half, 0, 0, and pi over 12 and negative 1/2. And now we graph it, and you're going to get your nice tangent curves there. So again, it's just like the other ones. Use your parent function and then do your transformations to it. I used to teach this completely different and used to have to figure out all the values and everything else like that. But once you figure out the transformations, it becomes a lot simpler to do.
Professor, can you explain the asymptote one more time?
So the asymptotes are basically where they don't work. So if you look at tangent has the values. Remember, we were looking at the domain, and it was every other value, or it was every odd value. So it was like pi over 2, 3 pi over 2, 5 pi over 2, and those. So it's all the places where cosine of x equals 0. Now, they want you to graph two asymptotes. So we could use the 0, the pi over 2, and on up. The problem with that, though, is it's not going to fit on the graph they're going to give you. So that's why I started in the fourth quadrant. I actually went negative pi over 2. So I went down to that bottom part, which is really the same as 3 pi over 2, if you remember the unit circle. So we're starting in that fourth quadrant and moving into the first quadrant. So that's where we're looking at those values.
Okay. Thank you.
No problem. And again, like I was saying with the sine and the cosine, I would just write that parent function down so you have it. And if you search online parent functions for trig or parent trig functions, it's going to give you those, and it'll give you these same 5 points that you can use. So, all right. Now, the next thing it's looking at, and I don't want to, we'll look at this one. We're looking at amplitude and period. So, and they actually do a pretty good job at this over here. So your period is, yes, parent functions. So your period is how long it takes to go from the beginning to the end of one cycle. So typically cosine and sine, your periods are 2 pi, because that's how long it takes to go from one to the other. Tangent, your period's pi, because it actually takes only pi or to go a full rotation. So to figure out your period, the period is 2 pi over b. Now b, so that's my period. And then my amplitude is the absolute value of a. When we're looking at this, when you're looking at your function, the a is what's in front. So it's always y equals a. In this case, they're using cosine, and then it's b x. So that's where we're getting the values. So that's my amplitude, and that's the value I'm going to use to do my period. So now we go back to the problem. We can look at this one. So we've got my amplitude is the number in front. It's always going to be positive, even if they gave you a negative number. So in this case, my amplitude is just what it says, 3/4. The period, I have to take as 2 pi, and I'm dividing it by, in this case, 4/3. So that means I flip it over, so I get 6 pi over 4. So it'd be 3 pi over 2 would be my period. So don't just take the number that's in there. You have to multiply it by it. You have to do the 2 pi over it. So in this case, I get 3 pi over 2. What that means is that the amplitude, the peak to peak, or the center to peak is going to be 3/4. So it's going to go from 3/4 to negative 3/4. That's where the amplitude comes into play. The period is how stretched it is. So typically it's 2 pi. That means it's 3 pi over 2 in this one. So that means it's compressed a little bit. So let's do one more of those. So, and it doesn't matter sine, cosine, they're all the same when we're doing our periods and amplitudes. So you don't have to know different rules for each of them. So in this case, my amplitude is 4. And then my period is 2 pi over pi over 4. So that means my period is going to be 8 pi over pi, or just 8. Your period does not always have to have pi in it. Most of the time it has pi in it, but it does not always have to have pi. So my period is 8, and my amplitude is 4. The next thing it's asking you for is your phase shift. So your phase shift is how much it shifted left and right. So when we're looking at our phase shift, so if you notice the phase shift, like right here, is where we're taking that function and we're moving it over. So if it's moving to the right, it's minus it. If it's moving to the left, it'd be plus. Moving up and down, those are your vertical translations. So those aren't a phase shift, those are your vertical translations. Now, your phase shift is going to be C over B. So now we're adding another letter in here. So we have our function. So it's A cosine, and then it's BX minus C plus D. So remember, my amplitude is the absolute value of A. My period is 2 pi over B. My phase shift is C divided by B, and my vertical translation is D. So those are the values that I need for this. So in this case, my amplitude is going to be the number in front, so that's 2. My period is 2 pi over 2 pi, which is 1. And my phase shift, so that's my period. My phase shift is C, which is 3 pi over 2, divided by 2 pi. So I get 3 pi over 4 pi, which is 3 over 4, is my phase shift. So my period's 1, and my phase shift is 3/4. Oh, negative 3/4. It's always the opposite sign. Because it's minus C, so in the problem, it had a plus, so you have to change the sign. So my phase shift would have been negative 3 pi over 2, which gives me my negative 3/4. Always the little sign errors. Let's look at 14 real quick. All right, so the next two, we're going to actually write the equations from the graphs. So when we're writing the equation, we're going to use that same setup there. The first question that you have to figure out is it sine or is it cosine? It will be sine if it's starting at 0, 0, because sine always starts at 0, 0 and goes up and then comes back down. Cosine starts at a high number and then goes down. So in this problem, we're using sine. So we're going to do A sine B of x. So the amplitude is the peaks from that center line. So this is my center line of the graph. So my amplitude is going up to 4. So that means A equals 4. So I have 4 sine. And now I've got to figure out my phase shift, or not my phase shift, my period. So the period, it's going from here to there. So it's 6 pi. So my period is 6 pi. So I have 2 pi over B equals 6 pi. So that means B equals 2 pi over 6 pi, or B equals 1/3. So it's going to be 1/3 x. So unlike in the last one where we had to do the 2 pi and we were dividing it by B because I had B, in this one we have to find the B. So I'm going to look at my period, which is from 0 to 6 pi, and then I'm going to plug that in to find my period, or the B. So in this case, I've got 4 sine 1/3 x. Y equals. Now let's try one more of these, and then we'll do the last set. So now this one starts up high and goes down. So we're going to use cosine. So it's a cosine B of x. From here up, we're going to 3. So my A is 3. And my period starts there. So it starts there and goes to 3 pi. So I have 2 pi over b equals 3 pi. So b equals 2 pi over 3 pi, or 2/3. So that's 2/3 x. So y equals 3 cosine 2/3 x. So again, it's using those values that we just looked at when we were doing the equations to now come up with a function for it. All right. The next one has a few things different about it. The next one's actually going to be all the letters. So figuring out which one it's going to be is a little trickier. So you really have to try to figure out where the starting point is. So if we're looking at this one, I'm looking at this as my curve. So that's one full rotation. So the first thing we have to figure out is, let's look for my A. Let's look at my amplitude. So that's my center line. So it's not going up 1, it's going up 2. So A is going to be 2. The next thing we look at is it sine or cosine? That is a sine function. So we're going to use sine. Now we've got to figure out, most of these problems do not have a phase shift, thankfully. Some of them do, but most of them do not. But they do have a vertical translation, and they do have a period. So we do have to figure out our period first. So my period in this case from here to there is 3. So I've got 2 pi over b equals 3. So b equals 2 pi over 3. So it's 2 pi over 3x. We're not going to have a phase shift, but I do have a vertical translation. Yeah, so hold on one second. I'll answer your question. My vertical translation of this is how far it's off of the 0. So this was shifted up 1. So my vertical translation is +1. Yes and no. So sine is y when you're looking at the unit circle and those point values. When you're looking at graphing the thing, though, sine isn't y. Your x and y is your stereo points. So it's not always going to be like, oh, it's on the y-axis, so it's going to be sine. It really depends on where it actually starts. So like if it was this point right here was over here, this would have been a cosine that I would have used, because that means it's starting off high and then going down. So I've got 2 sine 2 pi over 3 x plus 1. Oh, and I forgot the y equals. And that's it. So this, I finished all the topics in section 1 of chapter 6. This actually starts some of the topics in section 2. So between the Monday's lesson and tonight's lesson, you should be able to do every topic in chapter 6, section 1. And then you should be able to start working on section 2. I will finish section 2 on Monday's class. So you'll actually be ahead of the game. If you finish section 1, you can start section 2 immediately. Actually, everything technically unlocks at that point until Sunday night. So if you're behind in chapters 1 through 5, if you finish up section 1, you actually can go back and work on chapters 1 through 5 before Sunday. At Sunday night, or first thing Monday morning, chapter 6, section 2 unlocks, and everything else unlocks past that point or before a point until you finish up chapter 6, section 2. And the same thing will happen the next Sunday. If you finish up chapter 6 or section 2 quicker, you can go back and fill in holes for those other sections. So I'll be around for a little bit if you have questions. If not, you're more than welcome to log off and start working on topics and stuff like that. This recorded tonight, so I will be posting the video tonight for this lesson as well.